Creating a system with artificial general intelligence and having the ability to grasp and learn tasks like a human is the pinnacle of achievement in AI. AGI has long been thought to bring systems with the ability to think, plan, learn, represent knowledge, and communicate in natural language to the realm of science fiction. The infamous DeepMind has recently unveiled its new AI, Gato, which has similar qualities. Watch the video to the end as we give you all the details about why DeepMind's new AI thinks it is a genius. Not every AI expert believes AGI is achievable. However, DeepMind has taken a step in the right direction with the introduction of its new AI system, Gato. Gato is a general-purpose system which can be taught to execute a variety of jobs. DeepMind researchers have taught Gato to perform 604 tasks, including captioning images, conversing, stacking blocks with a real robot arm, and playing Atari games. Previously, most AI systems could focus only on a specific job or narrow topic at any one time. Gato has changed that as it can perform hundreds of different jobs, including controlling a real robot and performing basic captioning and chat. A single AI system that can do many jobs isn't completely new. However, when it comes to multitask learning, the essential question is whether the tasks complement each other. Then the model inherently splits the tasks before solving them. Google also recently began employing a system known as the Multitask Unified Model, or MUM, in Google Search to accomplish tasks ranging from discovering interlingual variances in a word's spelling to linking a search query to an image. DeepMind has demonstrated that their single models can handle a wide range of inputs. What's interesting is that Gato will keep learning, consuming billions of tokens in the form of words, visuals from the real world and virtual surroundings, button clicks, joint torques, and much more. These tokens are used to represent data in a way that Gato could comprehend, allowing the system to figure things out like breakouts mechanics or which word combinations in a text may make grammatical sense. Gato is not the first project accomplished by DeepMind. In 2018, the business released Alpha Zero, a program that taught itself to beat Go, chess, and shogi without the use of master games or instruction. Then came Mu Zero, which doesn't even have to be taught the game's rules. The new algorithm tried one action after another, learning the rules and finding the rewards. Such observational learning is ideal for any AI tackling hard-to-specify situations. Aside from the idealistic purity of games, such issues occur in the messy real world. It was also possible to use such AI in self-driving cars and protein design, the next step beyond protein folding. Mu Zero outperformed its DeepMind predecessors in the efficient use of data by learning the rules and, at the same time, enhancing its performance. Mu Zero performed admirably in the Atari game Pac-Man, despite being limited to 6 or 7 simulations every move. The system required some computational power to train, but once trained, it required so little processing to make judgments that the entire operation can run on a smartphone. In the case of Gato, surprisingly, the architecture isn't unlike many of the AI systems in use today, in the sense that it's a transformer, as it has traits with OpenAI's GPT-3. Since its introduction in 2017, the transformer has been the architecture of choice for complicated reasoning tasks, displaying abilities such as document summarization, music generation, object classification in photos, and protein sequence analysis. Even more remarkable, Gato has a parameter count that is orders of magnitude lower than a single-task systems, including GPT-3. Parameters are aspects of the system learned through training data. They are used to describe the system's ability to solve a problem, such as text generation. GPT-3 has more than 170 billion parameters, while Gato has only 1.2 billion. Gato was purposely kept small by DeepMind researchers so that the system could control a robot arm in real time. However, they believe that if Gato is scaled up, it may take on any job, activity, or embodiment of interest. It is also worth mentioning that Gato isn't always good at these things. For instance, when chatting with a person, the system frequently responds with a shallow or factually incorrect response. Gato also has a habit of misgendering people. Only 60% of the time does the system correctly stack blocks using a real-world robot. Furthermore, if you ask Gato a date-sensitive question, such as who the current president of the United States is, it is likely to give you an incorrect answer. Another Gato restriction is its context window, aka the amount of information the system can remember in the context of a task. Even the most advanced transformer-based language models can't compose a long article, let alone a book, without forgetting important facts and losing track of the story. Apart from these, DeepMind claims that Gato outperforms an expert more than half of the time on around 85% of the tests. Many experts believe this is a significant step toward AGI. However, we are still far from human intellect, and we are unlikely to get there very soon. I believe that many tiny models and systems are more beneficial, but there are clear advantages to these broad models when it comes to a task performance outside of their training data. To make Gato superior in cutting-edge single-task systems for certain activities, such as Gato's inability to constantly learn, Gato's knowledge of the world is built on training data and remains static. Some Gato models have begun to combine capabilities, such as DAL-E, which generates visuals from text descriptions with GPT-3. It is learning to recognize pictures and words using a single training strategy just like AlphaZero from DeepMind learned to play Go, chess, and shogi. The key difference between AlphaZero and Gato is that AlphaZero could only learn one task at a time. It had to forget everything before learning to play anything else. It wasn't able to learn two things at the same time, whereas Gato moves between these tasks without having to forget one before learning another. Nando de Freitas, one of DeepMind's top researchers and a co-author of the Gato article, is delighted with the development of Gato. He said that there is now a clear path from Gato to artificial general intelligence, a nebulous concept of human or superhuman level AI. He further said that building AGI is primarily a matter of scale, making models like Gato bigger and better. De Freitas' remarks have sparked a flurry of journalistic speculation that DeepMind is on the threshold of human-level artificial intelligence. We will have to wait to know whether that is true or not, but one thing is for sure: the future of AI is amazing. That is it from today's video. If you found this video helpful, then make sure to hit the like button and to subscribe to our channel so that you don't miss on any of the amazing and informative videos we have in store for you.